My name is Norbert van Nobelen. I've implemented Kubernetes at a small company, and I'm going into some of the aspects what we run into there. It is light on graphics, black text on white background, except the intro. The company where we, essentially I implemented Kubernetes was in a pretty traditional phase. We were running virtual machines, some physical machines, just deploying software using Jenkins to actually push it straight to an endpoint, so no orchestration at all on top of those environments. So we actually didn't always know if an installation went correct. It was a lot of work on the operations side, despite that we were with a pretty small team. And a strict division between development and operations. So in other words, developers, were not supposed to be on the production machines, and not supposed, we were on the production machines. And so we were pretty much stuck there, and we decided that we would actually build our own new management tool to get to a scaling, manageable environment. We were discussing this, and we were actually already starting with some basic designs when we were also discussing some other products with Google, and a Google salesperson notified us that there was a nice presentation in Seattle about a product called Kubernetes. Being in Vancouver, going to Seattle is not such a big deal, so I went over there and started to take a look at Kubernetes. It was a demo by Kelsey Hightower. He's mentioned here a few times before, and if you go on YouTube, you'll find a lot of interesting demos from him, and also what kind of issues you can run into when you're starting to use Kubernetes. Well, for us, we saw the demo, were convinced that that was a good way forward, but then came the installation. Well, we started with a 1.2 version of Kubernetes and trying to install that. That's an interesting experience. We're not really the first people implementing it. There were a lot of companies before us, and I don't know how they did it. The documentation was limited. There were literally terms in the document saying to be documented, and the only document which was there which gave you a full walkthrough was from CoreOS. And that was about 6-7 pages of documentation of going end-to-end with Kubernetes, like how to get and set it up. Well, 7 pages with a large environment, there are a few gaps in there. So what I did is actually get it running. Yes, it works, and then, oh no, I missed a point. Get it running, and another missed point. Well, that went on for about a month, and I got pretty sick of it. In the end, it was running, but it was not scalable. So fixed size cluster, well, that's not where we went for. So then we went for attempt number 2, which was there all the time, but I wanted to know how this thing actually worked. How does this Kubernetes environment work? Because once you run into issues and you don't know how it works at all, then you can just run a script, you have an environment, but what do you do when you have an issue? So the second attempt, and it should state kube up and not cluster up, was running kube up on Google Cloud, and that creates a cluster for you. Okay, nice, works. But there are some tiny issues there, at least in the 1.2 version, like a kernel where Google states on a single line on one of their help pages, like, that kernel is not good. well, why is it in that VM which you deploy? I asked Google support, and yeah, well, we don't know. Okay. So, built a new kernel. Actually, the kernel which was provided didn't even follow the resource limitations as set when you execute a deployment. You give certain resource limitations like CPU memory. Those get set on the real system using Docker. Well, those were not applied. So that gives you really interesting behavior. And the stability, even of a machine which was doing nothing. So just let it run over the weekend. You come back on Monday, machine crashed. What happened? I wasn't there. Nobody was there. So building a new kernel. The second part, which was interesting, that might be a bit our case, but we're running a lot of incoming connections. Was an advertising company. And our logging was taking about 25% of our CPU capacity. Well, that's not what we wanted to pay for debug logging. So we turned off the logging, but we did lose some other functionality with this. We didn't see all our debug logs anymore, so we had to build a new solution for that. But for the rest, it became a lot of fun. A thing which we did a lot was, well, mainly because of kernel issues. Oh, we have a new image. Let's replace all the nodes. So you delete an instance group, recreate an instance group, and sit back and relax, and everything comes back. And just to see that happening is, well, no virtual machine solution does that for you. No other known solution which I've worked with does that for you. So that is extremely interesting to see. Yeah, so we started moving applications in there, and we had some tech debt. So we decided to do a move and upgrade. That is the worst choice what you can make, of course. But we did get some stuff right. Running Java, the first thing what we did is build a base container with just Java in there. We really tried to follow the build once principle of Docker. So build of branches instead of building of master, which we did before. Continuous integration is sometimes a more difficult term, so the pipeline approach which Hootsuite uses is more advanced than this. But at least we had a build once, means that it can go to QA once, and then next time when we deploy an environment, it will again be just that singular test moment and straight deployment. And the last part is the building for failure. Well, seeing where we came from, implementing health checks and readiness probes was also an interesting exercise. When we deploy in production and we deploy in a running environment, we're having to handle hundreds of requests per second at once. Readiness probes are not really suited for that. What actually happens when you deploy and you don't have anything running at that point in time, so your ingress is already active, you have incoming connections, but in this case, due to a bug in Kubernetes, instead of doing a nice rolling update, replacing by one, it decided, like, you know what, I will terminate everything at once for you and redeploy a nice new set of pods. Well, our new pods had readiness probes on it. So it took a few moments for them to say, like, yeah, I'm ready, I'm going to accept connections. And they also have a liveness probe. Well, what happens? One pod is ready, overloads, crashes, and then the second pod is finally up and running and ready and says, like, oh, yeah, crap, now I'm overloaded. And that can take a while before you have fixed that one. So despite having the building for failure, the automated correction for that, it doesn't work in all scenarios. You sometimes have to do more to just keep your application going. Then, Then we have a few more learned lessons. another scenario which we clearly had was a multi-container pod approach, in which we, for example, had our application and log processing for other use. Well, our application, in some cases, was using less than 1% of the total capacity required for processing that data stream. So the incoming request from the user was processed with about 1% CPU, and the other 99% which we required was for log processing. Well, and we had that in two different containers in that same pod. Well, every pod gets its own resource allocation. Sorry, every container gets its own resource allocation. So what you do is you're going to say like, okay, 1 to 99, so I'm going to give my application, well, about 1% CPU and my logging 99%. That's not going to work, because what happens, again, with the Docker CPU slicing, is that 1% allocation, in this case I used a 5% to make a little bit shorter line, is going to get you a request latency, which is fairly long, while if you give it just a full CPU, you get a very short latency, but you would get a really spiky use of that single container. And you're wasting 99% of your CPU in that given container. But you're sort of stuck with it, because your log processing takes 99% CPU in a different container, which is part of the same pod, but the resources are managed independently on container level, not on pod level. So what happens is you have an application running using two containers in this pod, one CPU you never use, so you're wasting a lot of resources. Then again, the Docker design pattern tells you like, yeah, run a single process in your pod. Oh, sorry, a single process in your container. Well, that part you might want to break when you're running in this kind of issue. In general, sidecar containers in pods run into these kind of issues, like how do you distribute the resources and how do you scale? Autoscalers don't like this. Then also look at your processes itself. Depending on what language you use or which application you use, you might already have a multi-threaded application which is able to use multiple CPUs. But you also want to be able to actually bin pack your system, so you want to reduce the size of your application. You want to make it or have something which is horizontally scalable. So you're going to want to look at like, okay, that multi-threaded process, what happens if I run it single-threaded and just a bunch of them? Well, if your application is capable of doing that, go in that direction. In case your application is not capable of doing that, like for example, if you're running a MySQL database in your environment, in a container, then you're pretty much stuck with running large pods which are not too good in bin packing. Single pod workloads, I pretty much went into that already. It also helps you again with the healthness and liveness probes. Because if you have a bunch of containers in a pod, how do you determine if something is actually live? Again, there were a few bugs in the versions which I used in this project, where actually the liveness probe on the first pod, if that, the readiness probe on your first container in your pod, if that said like, well, okay, something is ready, then the timeout, which is required on the second container, with that readiness, with the same readiness probe or a different readiness probe, would act a bit weird, not really defined, let's say it like that. So let's say you would have 30 seconds to get the first container up and running, and you would need 40 seconds to get the second one up and running. It might be that Kubernetes was already killing your pod again because the second readiness probe was not online fast enough. that so the definition of the readiness probe is not stretched to a pod level. It was really on container level, and yeah, I don't know if that changed in the later versions. This was on 1.3 still, so might be better on the 1.4 or the 1.5. The last point which I want to stress actually is what is happening with Kubernetes is if you look at a 1.2 or 1.3 version, it's pretty straightforward API. And with some creativity at some point, you can actually do all the activities which now special components are being built for. For example, stateful sets, they're nice, but do you really need them? Look at your application again. See if you can use a more simple approach. Probably just running a bunch of pods is more flexible and makes your actual design prettier again. Installation at this point in time, also in Google Cloud or with KOps, is fast and easy. But new functionality bloat, which you are then in control over what you want to do there yourself, can make this installation a really prolonged process. So, as with any platform, it really depends on what you are willing to do about your own code, which was not following any standard at all. You defined your standard yourself. And the platform. And I'm actually leaning towards like, yeah, okay, change your own code. Don't try to change the platform.